Good morning, everyone. Welcome to day 2 of the Ocean Vision Summit. 2 quick housekeeping announcements for everyone that's here. Come on and have a seat. Walk away from the fish. Back away from the belugas. I know they're tempting. All right, so 2 just quick housekeeping announcements. Share with your friends for those that aren't here. The first thing is about lunch. So we had several requests for special dietary needs. If you do not see something that you can eat, please ask the banquet staff. We have the meals available. We just want to make sure they get to the right people. My understanding is they were all consumed yesterday. I just don't know if they were consumed by the right people. So just ask banquet staff. And then the second thing is just about noise. So this is a big wide open space. So if you are in the back grabbing coffee, looking at the fish, getting a snack today, just please remember that your voice carries into the room where people are speaking. We've got full days in this room and a pretty full day in the Atlantic Ballroom as well. Thanks, everyone.
Okay, good morning, everybody. Come on in and have a seat, please. Join us for day 2. Day 2 is always a bit of a slower start than day 1. So thank you all for coming and being here. Yesterday, I gave an overview of the kind of 4 key tracks of the conference, and we refer to them as the 4 R's for an ocean climate agenda: reduce, remove, repair, and reach out. And this is the beginning of track 3, which is repair. So this is a pretty new area, I think, for a lot of us to be talking about. And we're gonna be guided this morning by a couple of experts in this area. But I just want to give a quick introduction to this. The idea behind Ocean Visions and others, but in particularly us working on this, is that it's important to keep your eye on the whole while you're working on a problem to make sure that you don't lose parts, right? We are, with the climate disruption that's going on the planet, we're essentially pulling cards out of a house of cards, or choose your analogy, right? At some point, parts of the system become unstable enough or they change enough so that it affects the whole system. This has been referred to as tipping points, and this map shows you just a series of what some of those are. I've seen other maps that have 35 different tipping points. But the important part is just to look at this definition: critical large-scale components of the Earth system characterized by a threshold behavior where they remain stable up to a point and then they experience nonlinear change. And that could happen anytime. Some people might argue that in certain parts of our Earth system, these components have already reached those points. The problem is when they do reach those points, they can cause all sorts of further accelerated change, which is what I know all of us would like to avoid. And in fact, some people have talked about the cascading effects of these tipping points, and how they can amplify one another. And this is just a bit of a diagram of some of the connections between things like Arctic ice and a host of other critical elements. So it's important that while we work on decarbonization of our economy, and while we work on cleaning up carbon pollution, we don't lose sight of the fact that there are critical pieces that we also cannot afford to lose. So this session is all about not losing the pieces. I think one of the title was Keeping All the Parts, and that comes from those of you who will remember Aldo Leopold's Sand County Almanac. The first rule of intelligent tinkering is to keep all the parts. I would modify that for today's world. The first rule of really unintelligent tinkering is to keep all the parts. So we're unintelligently tinkering with the system, and we better focus on the parts. So I've got a couple of great colleagues to really set the stage here. I'm going to introduce both of them, and then we're going to hear first from Olivermorton, who hopefully we can get up on the screen. Oliver is senior editor, essays, briefings, and technology at The Economist. before he's been at the Economist since 2009. Before that, he was actually the news and features editor at Nature, and he has an illustrious journalistic career. He's also an author, and he's written most recently The Moon, A History for the Future, was listed as a Science Book of the Year by the London Times. But his previous book, more relevant to today's topic, is called The Planet Remade, How Geoengineering Could Change the World. And so that's highly relevant for the discussion we're going to have this morning. We're going to hear from Oliver first. I still don't see him on the screen. If we could bring him up. Oh, he is up there. Okay. And then, hi, Oliver. Second speaker after Oliver is Kelly Wanser, who's the executive director of SilverLining, which is a nonprofit organization dedicated to ensuring society has sufficient information and options to address near-term climate risk. She co-founded and is senior advisor to the University of Washington's Marine Cloud Brightening Project, which is also highly relevant to this topic. And she has served as a strategic advisor to the Ocean Conservancy's Ocean Climate Risk Analysis, to Lawrence Livermore, and she's a member of the President's Circle of the National Academy of Science, Engineering, and Medicine. Prior to that, she was an entrepreneur, and prior to that, she was in academia. So she also has a journey story, like we heard yesterday from people about this journey from academia into direct action. So with that, Oliver, please take it away.
Thanks, Brad. And I have to say, I'm feeling severely beluga deprived over here in London. We sometimes get whales up the Thames, which is outside my window, but there is nothing today. So enjoy your aquarium frolics. And so I was asked to bring a bit of sort of like the broader context to this discussion of what I tend to call geoengineering and Kelly tends to call climate intervention. And an important thing to remember is that for as long as people have thought about the climate as a global, scientifically accessible thing, they have thought about changing it, both incidentally and deliberately. And in the deliberate change, they focus quite strongly on the oceans. Now, at the moment, speculation about deliberate climate change, deliberate climate modification, tends instead to focus on the atmosphere. And I think Kelly will be telling us about that. But the relevance to the oceans remains, as Brad said, completely vast. And this is in part because the oceans could be a platform for such climate modification, and partly because they might benefit from it or be fouled by it. But mostly it's because, to a first approximation, the ocean is the climate. 90% of the heat in the Earth system that has been added as a result of anthropogenic climate change is in the oceans. The atmosphere causes global warming. The ocean actually does the warming. So going back to the historical stuff, much of that early speculation was about the Gulf Stream and how its course might be altered either through the Isthmus of Panama or away from Europe in various different ways to various different ends. And you must remember that this was speculation happening at the time of the great canal building boom. And so the Panama Canal and Suez Canal, the idea of connecting ocean basins was in the air, as it were. But the other great focus for this sort of thing was the Arctic ice, the cryosphere. One of the very first popular treatments of what can be done with nuclear energy by Frederick Soddy, one of the chemists who basically invented the study of nuclear energy, was to talk about melting the ice caps, about bringing about an Eden on Earth by having this amount of control over the climate. This wasn't just one speculation. When UNESCO was founded in 1945 by the United Nations, its first Secretary General, Julian Huxley, a notable British biologist and eugenicist, suggested that nuking the Arctic ice might be a good way to make the world a better place. And it wasn't all nuclear. There were other suggestions for how one might get rid of the Arctic ice, for instance, by damming the Bering Strait so as to change the course of the currents through it so that they come out of the Arctic, so warm water goes in, or by smearing it with soot, which I think these days we would call radiation management, so that the ice warmed up more than it does normally through the blacking effect and thus melts. And although those schemes, and they were sort of like, in a way, sort of like playful schemes, but also not entirely playful. People weren't just joking. They were trying to come to terms with the idea of humans having agency on a global scale. So those schemes don't only focus on the horizontal distribution of heat, the distribution across the oceans or between latitudes. They also some also looked at horizontal distribution of heat. The great British astronomer and astrophysicist Fred Hoyle became convinced, erroneously and eccentrically, that there was an ice age coming. And he suggested a geoengineering scheme whereby the Earth's warm water should all be pumped down into the ocean, into the abyssal depths, so the cold water would come up, and so that could be warmed too, so that the ocean could be consciously turned into a heat battery to stop the ice age from returning. And he wrote about that in the 1980s, at exactly the time when the opposite problem was becoming uncomfortably evident. And so, given that there was always this interest in tinkering, always this interest in geoengineering, it's kind of interesting that once climate change becomes a real thing, you might have thought that people would sort of like step on the gas and say, oh, we must do more and more and more of this. In fact, the absolute opposite was the case. There was, from around 1991, 92 to around 2006, barely anything published on the subject. And there are a whole bunch of reasons for this. There is a becoming fear of hubris. There's an understandable fear that techno fixes don't work or go wrong. There's an endless refrain of, oh, but have they thought about the unintended consequences, which, like, people do tend to do. But also, most importantly, there's this idea of mitigation deterrence, mitigation erosion. The idea is that if humankind, or a significant part of humankind, has control over a way of cooling the Earth, then the impetus behind reducing carbon dioxide emissions will weaken. And I think there's very little doubt that there's a possibility that that would happen in the case of geoengineering as a cooling mechanism being taken forward. And it's a particular problem with the oceans because of ocean acidification. Because although cooling the planet doesn't do absolutely nothing to ocean acidification, it certainly doesn't help the problem. And so for anyone interested in the health of the oceans, you have to bear in mind that there's an extra worry about mitigation erosion, because the oceans would no longer benefit from the reduction of carbon dioxide, or no longer, it's not like benefiting, it's not getting worse. And I'm not sure I've got the right word for that right now. So ocean acidification, always a problem, something that the sort of geoengineering schemes that most people are looking at the moment, and certainly all the ones that might have any sort of short-term application, doesn't address. So I think I'm going to actually skip a few other things, because I think we started off a little bit late. And Kelly is going to talk about the actual scientific possibilities. But I just wanted to bring up one other thing, as well as mitigation erosion, that's a besetting problem here. And this is that of governance / geopolitics. Lots of people say very sensibly that one would like a global governance architecture to be in place before any geoengineering were to start, if it were to start. And I should make clear my own position, which is, I think these are very interesting topics, and I think they're important topics, but I don't think at the moment the world is in a position to do anything on this in a responsible way. I kind of would like to be in a position where we could make decisions on a responsible way, not there at the moment. But governance in advance is very, very unlikely and highly unlikely to be global. And so whatever sort of geoengineering for cooling purposes might be undertaken, you can imagine that there will be some group that might be most of the planet, but might not be most of the planet, might be just a few nations that is doing it, and another group that is either acquiescing in it or not. And this is a way in which climate change caused deliberately in the name of geoengineering is quite unlike anthropogenic climate change of the sort we're used to, of course, through greenhouse gases. You can't stop anthropogenic warming through greenhouse gases by attacking one particular nation or set of nations. And you probably could in geoengineering, because it will always be a subset, and quite likely a small subset of all nations that are involved. And so in terms of its capacity to exacerbate geopolitical tensions, geoengineering has side effects that the climate change that we're used to, because geoengineering is obviously also a form of climate change, the climate change we are used to does not have quite the same characteristics. So the things that geoengineering as a response, never I think a solution, a response to climate change brings with it are significant risk of mitigation erosion and a risk of conflict of sorts that are not normally associated with climate change. At the same time, to concentrate on the risks is to ignore the fact that solar geoengineering can actually deal with near-term issues in a way that other approaches to climate change simply cannot. There is no other way to deal with cumulative emissions other than reducing the incoming sunlight or taking some of those emissions out. And of those two, only reducing sunlight is quick. So it does promise is the wrong word. It does offer the possibility of near-term reduction of harms, but it brings with it specific risks in terms of mitigation, erosion, and geopolitics that otherwise would not be there. And with that, I will hand over to Kelly.
I hope I got the right one. I did not. Hi, everyone. Thank you, Oliver, for that. Oliver and I have known each other for a long time, and his remark about this, these ideas that we're talking about not being a solution, but rather a response, a temporary response to acute near-term problem, we really agree on. And one of it's one of the reasons we refer to these things as climate intervention. One way to think about this area is engineering. Another way is medicine. And so if we look at the complex systems problem of trapped heat energy, especially with regard to climate risk in the ocean and the big macro risks that we're facing, we have, let me see if I can advance this. Whoops.
Just use that clicker over on the...
Use the clicker. Okay. We have a specific problem that the trapped heat energy in the system is projected to rise over the next few decades. So the risks that we're carrying today in terms of impacts and in terms of increased threat of tipping points, those are projected to grow. And the current portfolio of solutions that we have don't operate on that time horizon, which is why the UN projections look like they do. So we're getting this array of things that you guys have been talking about in terms of climate repair, carbon dioxide removal, ocean solutions to try to accelerate pulling greenhouse gases out of the system, but also whether we can directly push trapped heat energy out of the system. And when scientists look at the question of what would be the fastest possibilities for pushing trapped heat energy out of the system, they landed back at one of the big ways that the Earth system regulates itself, which is the reflection of sunlight from particles and clouds in the atmosphere. This is a NASA visualization of that. And scientists, where they landed is thinking that if you increase this reflectivity of the planet by just 1%, that you might be able to offset 2 degrees or more of warming. And one of the reasons that they think that, and I'll kind of skip over this slide a little bit in terms of where they landed in ways of doing that. But one of the reasons that they think that is because they've seen it before in, actually I won't lie that, I'll explain. And so the ways they're thinking about that is by pushing dispersant particles at different layers of the atmosphere, either the outer layer or the stratosphere, where sunlight bounces off the particles directly, at the low cloud layer, particularly in the marine environment where pristine clouds are over the dark ocean, and you get a potentially large reflective effect. And possibly in the middle layer where the insulating clouds in the high troposphere could be altered to release more infrared energy. And so they've arrived at these particular approaches that they think are candidates for rapidly reducing heat energy in the climate system. One of them is brightening clouds over the ocean, which you might hear more about in other sessions. This idea is based on what they've observed in terms of the influence of particulates from ships on ocean clouds, and the bright streaks that you see in the cloud deck here on the Pacific West Coast are made by the emissions from ships. Overall, globally, emissions particulates are actually estimated to be cooling the planet at a significant level. And so one of the things that I'm going to stress is that the science that we need to do, the things that we need to know to look at the question of whether increasing the reflectivity of the atmosphere could help reduce warming for a temporary period, are the same questions that are some of the largest uncertainties in our ability to project climate. So what I'm going to say to you is most of what we need to do quickly is to better understand our aerosol effects in the atmosphere, and that will help us know whether these temporary ideas are candidates for cooling the atmosphere quickly in a more concerted or intentional way. In the notion of brightening marine clouds, the idea is that you use sea salt spray from the ocean, optimized to maximize the effect, and targeted at specific areas of marine stratocumulus cloud, where by brightening those clouds by a fraction like 5 to 7%, in an area approximately equivalent to 5% of the ocean surface, you might offset a doubling of CO2, in theory. This effect is temporary and local, and one of its biggest impacts is that it cools the circulating air and water. And that cooling of the circulating air and water, in theory, might be something that could, in a more local or regional way, help preserve coral reefs, or help reduce the force of storms. I say in theory because this is really almost not studied at all. Marine cloud brightening has the characteristic of this high degree of uncertainty that we carry with climate uncertainty and the aerosol effects. But the most prominent approach in this category arises from observations of what's happened when large volcanoes have erupted and pushed material out into the stratosphere. When Mount Pinatubo erupted in 1991, pushed material into the stratosphere that cooled the planet for a period of time, about a year and a half. And one of the results of that was actually a restoration of Arctic sea ice. I'm looking at my clock here. And so for most of you that I see in this room who were alive in 1991, you've actually experienced this already. And most of the world didn't notice. So both in the cloud layer and in the stratosphere, everyone on the planet has experienced this before in an unmanaged, unoptimized way. And that's our starting point. What I'm going to say to finish off is that, this touches on long-standing gaps in information, long-standing uncertainties in our observations, our climate models, and our science around aerosol influences on the atmosphere and the intersection between atmospheric influences and climate projection. And I'll finish off with, there's lots of cool things we could do, and this research is starting to happen in a very small way relative to the scale of the problem and the uncertainty. And I'm going to finish off by saying that these long-standing uncertainties intersect with the problem of solar climate intervention and its potential to be a temporary stopgap in the warming process. Climate research globally, investments in climate research have been relatively flat for the past few decades. And compared to the escalating investments in other parts of the climate problem, climate research itself, and by that I mean the direct observations, the climate models and climate model development, and the basic climate science have been flat. And in the US, they've actually slightly declined, especially basic science in the atmosphere. So we have an opportunity here in our efforts to look at this category of climate intervention to also improve our ability to project near-term climate, which is the problem that we're trying to do when we look at these things. So there's a lot to say here. I'll refer on our website at silverlining.ngo. We have a report on this topic for more information. And I look forward to picking up the dialogue with all of you.
Thank you. There is a lot of food for thought in both your comments and Oliver's. Unfortunately, we have very little time, so I'm going to limit it to a couple of questions. Can we get Oliver back on the screen, please? So first, starting with you, Oliver, this whole issue of the world's ability to act in any kind of a concerted way versus individual actors acting, how do you see any legitimate procedure in place at the international level that could resolve that problem in anywhere near the time frame that we have to decide whether or not we have to act? And if not, how do you see this happening moving forward? Do you see individual actors just seizing the reins, or what's your forward projection on this?
I would tend to think that there are two things. One is that you can't let the best be the enemy of the good in this sort of thing. And so you can't say, oh, well, because we can't get any sort of governance in place, we shouldn't be looking for even a bit of governance. And the first thing I'd say, and this is easier said than done, is to simply make international organizations think a little bit about this. And the classic example here, which will be familiar to some of the audience, is the International Maritime Organization, which has reduced the amount of sulfur being produced by ships on the high seas. And it has good reasons for doing so. But at the same time, because those particles do have an effect on human health. Those particles are also, as was shown in one of Kelly's slides, a significant part of the aerosol layer in the troposphere that's keeping things a little bit cooler. And so we've had a large-scale decision about this taken with very, very little concern for the climate. And that sort of ignorance and avoidance by international organizations, the inability of the IPCC to integrate these ideas into its substantive thinking on these subjects, these are real problems. If we could move that at least a little bit, you would see the world of discussion over policies start to take more notice. So it's pushing at the places where discussion of this isn't happening but should, which is, I think, probably your best way forward to getting at least some sort of take about, as on a panel that oh no, you weren't on it, Brad, that was a different panel, but something that we both did together recently. The question was not, should we geoengineer, but what do you do when someone geoengineers? And that is the question to ask yourself about governance here.
There are a couple of recent developments that are in line with Oliver's sort of point of view. One is that the Scientific Assessment Panel of the Montreal Protocol included, for the first time ever, a full science chapter on solar radiation modification in the stratosphere in the recent 2022 ozone assessment. And if you're interested in the state of the science and the stratospheric version of this, that is the latest thing. And so they're almost the opposite of the IMO in terms of stepping forward on serious science and what would this do in the stratosphere, which is kind of ground zero. So that's a good development. There was also a recent workshop report from UNEP on this topic. So we're starting to see some incremental steps forward on the science side.
Thanks for that. The question I wanted to ask you is, we framed this in the very beginning as tipping elements and keeping parts of the system alive or functioning or stable or from destabilizing. But I got the sense from your presentation that you're definitely looking at this as more of a whole system. What do you think about what do you think about the viability of more regional and sub-regional focuses on some key parts of the system, like these cards that I thought of in the House of Cards analogy? Was that just not?
It's a great question, and we work with senior scientists at the Met Office and the Department of Energy. And I was asking them, because I'm doing a talk in the cryosphere, I was just always asking them about, polar restoration and targeted things. And they really, like, 3 of them just waved back and said, you have to remember the teleconnections, that the warming that comes into the poles comes from the equatorial regions. And the teleconnections are kind of an overwhelming force in the system. And so if you try to push a lot of forcing on one part of the system, you actually can have more instability than by forcing on the system as a whole. So it's a little bit counterintuitive, because a lot of people think that these localized or regional things, they're appealing because they seem like they would be safer and more managed. But because of the interconnectedness of the Earth system, all of this with the big caveat that we're really at like a tiny level of research relative to what we need. So there may be possibilities here, but it's not always the way it seems.
So the last thing I want to ask each of you to do, and I'm really sorry, I would love to have a lot more time for this conversation. And Kelly is going to have a chance to talk a little more during the polar ice or the cryosphere discussion. But there are a lot of young professionals that are in attendance, either here or virtually. A lot of people thinking about their career in ocean science and conservation and the world of climate tech. What advice would each of you give to people about the relative importance that this topic might play in the future of their careers, and how to think about that? I'll let you go first, Oliver.
Thanks, Brad. It is going to play an important part in the future of your careers if your careers are going to be in ocean science, for the simple reason that in the long run, removing carbon dioxide from the atmosphere will likely be done through weathering, and that will have effects on ocean chemistry and ocean biogeochemistry. You should also think about it, because I think at this stage it's getting irresponsible not to. You can't pretend that the only thing is to stop everything and move back to the ocean as was. Not an option. So to some extent, thinking about the deliberate and the incidental effects of human activities on the oceans has to be part of your thinking, and it has to go beyond the paradigm of simply deploring what would we call interference, simply deploying human activity, because that's not going to go away. And so thinking about a way to balance what might do good and what will do harm and what the risks are, that's going to be part of being a responsible citizen of the oceans for the rest of the 21st century and for the 22nd as well.
Thank you. Kelly.
I think one of the exciting parts about it for early career scientists is that these ocean solutions, these atmospheric solutions, they center on basic science processes that, haven't been necessarily the sexiest or most exciting, areas where, they are to certain sets of people. But now this is really focusing, we want a high standard of evidence. How does this process work in ocean carbon flux? How does this work in aerosol forcing? And so as a career scientist, if you stay in that lane where, you're looking at the science related to these techniques, I think it creates really durable, but also very exciting career opportunities.
Great. Thank you both. As we transition, I want to just give you an overview of the rest of this track. So this was sort of a scene setting. We're now going to take deeper looks into parts of the system, corals in particular, and then the cryosphere. And then we're going to have a discussion with an interesting group of perspectives around the ethics of this whole area, because they are extremely complex. They're not clear and straightforward. They're very complex. So first, I just want to thank Oliver and Kelly, please. And then second, I want to turn the mic over to my co-chair for this track, David Kowick, our chief scientist, who's going to lead the session on coral regeneration discussions.